Hello, welcome back to another lesson with Mr. Fieck. Today we're going to talk about think before you multiply. The last couple lessons we talked about standard algorithm multiplication, showing you how to multiply using standard traditional multiplication with a multi-digit times a one-digit number and a multi-digit times a multi-digit number. So this is just kind of thinking about think before you multiply. Take an extra second and just think, like, what would be the most efficient method for me to solve this multiplication problem? So the learning target is just that you understand that multiplication problems can be solved in many ways. There's no one right or wrong way to solve a multiplication problem. Okay, so we're going to go through some examples, and I even did a three-digit by double-digit number so we can see how those are done too. So if I have 56 times 3, what would make the most sense for me to multiply? Well, I could double 56 and then multiply it that way. I could do the double and halving strategy, okay? Or I could just do the one that we've been practicing the whole year, is the area model. I could just simply go, let's do, well, 50 plus 6, and this would just be 3 because it's a single digit. So 3 times 5 would 15, so that'd be 150. 3 times 6 is 18, so 150 plus 18. Oh, hey, that's 168. Okay, so it's a little more work writing the area model, but if that makes the most sense to you and that's what you understand and get it, use the area model. Okay, this one, we have a 3-digit by a single-digit number. Nothing changes from what we learned, except instead of just doing the 7 times 1 and 7 times 2, you have to do that one more time to do the 7 times the 3. So let's do standard algorithm. Let's do 7 times 1 is 7. 7 times 2 is 14, so I carry the 4, and I have another digit to add, so I carry my plus 1. And then I do 7 times 3 is 21, plus 1 is 22, and there's nothing else. So I just put my whole 2 down there, and the answer is 2,247. That was pretty efficient, and we got the answer fairly quick, right? All right, now let's get into something we haven't talked about yet, is a 3-digit times a double-digit number. And just like I said over here, nothing else changes except we just have to multiply it one more place value because now we have the hundreds over here. Okay, so if we were going to do area model, I would have to make a 3 by 2 because I'd have to go 400 plus 80 and plus 2. Then I'd have to have my 20 plus 6. And there we go. Now I got my 3 by 2, okay? But I'm going to start by doing standard algorithms so I can show you how to do a 3-digit number or larger. You could do as many numbers as you want, or maybe you want to pause it now and try solving it yourself and see if you get what I come up with at the end. So I'm going to go 6 times 2 is 12. Put my 2, carry my plus 1. 6 times 8 is 48, plus 1 is 49, so I put my 9, and I'm going to carry my plus 4. 6 times 4 is 24, plus 4 is 28, and there's nothing else to add, so I just put my 28. So now 482 times 6, I got 2,892. So let's see, 6 times 400 would be 24, and 0, 0, so 2,400. 6 times 80 would be 480, and 6 times 12 is, or 6 times 2 is 12, so that'd be 492 plus, well, 400 plus 400 would be 892, so yeah, that would get me the same thing. All right, now I'm switching to my 2, so right away I go to the next row and I put a 0 in. Now you do the exact same thing. You go 2 times 2 is 4, 2 times 8, and I'm just going to scribble these out so I don't get confused by what those are. So 2 times 8 is 16, and I carry my plus 1, and 2 times 4 is 8, plus 2 times 4 is 8, plus 1 is 9. So 20 times 482 is 9,640. And then I would just add them. But now let's go up here and do the area model. 2 times 4 is 8. And that would be 1, 2, 3. So I put 1, 2, 3. So that'd be 8,000. 20 times 80. Well, 2 times 8 is 16. And I have 2 zeros behind it. So right there, that'd be 9,600. Oh, and 20 times 2 is 40. So that would give me the same thing. Now I just have to add. So 2, 9 plus 4 is 13. Carry my 1. 8 plus 1 is 9. 9 plus 6 is 15. Carry that. 9 plus 1 is 10. Plus 2 is 12. So I would get 12,532. So 482 times 26 is 12,532. And it would be the same thing if there was another digit in front of the 2, if it was 326, then when I went, I would have to put a 0 and a 0 and then start multiplying. Same concepts kind of apply, okay? So I hope this helps, and I hope the standard algorithm makes sense. Remember, it's all about becoming efficient mathematician. What makes the most sense and helps you to be the best and most efficient mathematician you can be. Go make it a great day, boys and girls.